Hi, well I'm standing outside here just next to our water tanks here. Here you can see them. We have about 1,000 litres of water, that's 1 cubic metre that we can store. I've just put the washing machine on to use some water, and looking at our bill from last year, it says that in fact between the two of us we used on average 235 litres of water a day. And if we were a normal two-person household, that would be 274 litres per day. So is that the entire story? And are we doing all that well? Let's see as we look a little bit more into the full story of how we use water. The cover photo was of Loch Tay, and the picture is taken very near where the River Tay exits from the loch. Really, that's our view of accessible water, trapped in a natural reservoir or leaving by the river to flow and be used further downstream. From this pie chart we can see the distribution of water in different locations. The vast majority, as we would expect, is from oceans and seas and bays, nearly 97%. Then the two other larger locations are as ice and snow, and also as groundwater. Each of these is about 1.7%. So our lakes and rivers, etc., are within this bracket of the rest. That's 0.04% more or less. And really in what we do, we don't want to wreck our rivers and our lakes. So the best way to get sustainable water is to take it from the sea. And where there is a natural desalination process called rain. The evaporation leaves the salt behind, and then the rain gives us our distilled water. Unfortunately, it collects things on the way down if the air is not very pure. It's thought there is around 500,000 cubic kilometres of rain a year. The majority of this will be over sea, and this leaves around about 100,000 cubic kilometres of rain over land. Much of that comes down into river flow, about 47,000 cubic kilometres. And it has been estimated that the maximum you should extract from a river, or think of extracting from a river, is around 20% of that. Presently, we extract about half of that. And we consume about a third of that again. The difference between extraction and consumption is that the extraction will come from a water source, and quite a bit of it will return to the water source. So the consumption is that which is not returned. To try to personalize it a bit, this bar chart shows the amount of water extracted per person in cubic meters per year. You can see there are stark contrasts between the United States, for example, and Ghana. In several countries you can see the extraction is about 400 cubic meters per person per day. That's roughly 400 times the amount of rainwater that we are storing around our garden. Now if we look at the consumption, that bit which is not returned to source, we should see a breakdown of this main figure. It is obvious from this graph that agriculture dominates this, and then there is industrial use of water, and then there is also the use for power generation. These figures are in cubic kilometers. It would be good to see how this breaks down again towards our personal use. Note that in that plot in the last slide, we didn't see anything about municipal or domestic use. So there's all of those large ticket items are outside what we normally think of as our water use. So there is indeed a hidden use of water, which generally is called virtual water. We'll see in another video that carbon and energy are called embodied carbon and embodied energy. Virtual and embodied mean exactly the same thing. And often this is normalized against 1 kilogram of the material. So this table here gives some values for the virtual water of 1 kilogram of material. The top one is aluminium, and that comes out at 1200 litres per kilogram. That's on average what is required to produce 1 kilogram of aluminium. You can think of that as making up part of the cans. Other things to hold liquid will be PET, that's a much lower figure, and glass, which is a much lower figure again. The materials that we choose in the everyday items that we have affect our water footprint. Structural materials also have their water footprint. For brick it's very low. For plywood it's somewhat higher because obviously trees require water. Then for items that we may use as textiles, here are 2 examples of flax and cotton. Even compared to aluminium, cotton and flax, these are larger uses of water. And we saw before that agriculture is one of the main uses of water. That's possibly not surprising, but our choices of what we eat make a large difference on our water footprint. So potatoes use perhaps 10 times less water than rice. An apple is a lot less water than chocolate, and chicken a lot less than beef. The water footprint network provide a couple of methods of estimating your own water footprint. There is a very detailed one where you can go through the food that you would eat and other activities. Or there is the broad brush one, which I have used here just to get an idea of what things are like in terms of our use compared to the 235 litres per day that we had together. Compared to our overall use, my water footprint is about twice that of the overall average across the world. And you can see again that the major uses are industrial or materials, stuff that we buy, and also the stuff that we eat. And we can see a breakdown here of what it might be like for an average meat-eating person in the UK. We should really consider our demands for water in the way that we live in the same way as we do energy and carbon. We're going to look at the effect of embodied energy and embodied carbon on our overall footprint in another video.